Welcome back at the Technical Forum at the group exhibit Hydrogen Fuel Cells and Batteries. We're here at the Hanover Fairground, and our partner country are the United States of America. Also, I would like to say to all our international guests that are watching us on our online stream through our website h2fcfair.com. This is the Technical Forum. My name is Mona and I'm the moderator here. And our next topic will be low-cost fuel cell monitoring with total harmonic distortion analysis by AVL. So please welcome with me on stage Project Manager Mr. Richard Schauperl. Big hands, please.
So thank you very much for introducing myself. So my name is Richard Schauperl. I'm with AVL. I'm going to present you about more or less a new approach about stack monitoring for PEM fuel cells. So as usual, stack consists of several cells, and the standard approach is that every single cell is connected with wires, and the cell voltage is measured by each cell. If you can imagine, if you have a larger stack, for example, an automotive application, then you have 300 or 400 cells, and this means you have to wire you have 300 or 400 wires, and that's very let's say complicated, and that's a lot of costs. And even with this approach, it's not possible to determine the failure cause of the stack when the cell voltage is dropping. So what we have learned in the past is that there is a requirement for real-time indication of failure modes and online monitoring of stacks, and not only the detection of the drop itself, so to also get an idea about the reason of the cell drop and to set immediate counteractions that the stack will not be damaged. So what is our approach? We are measuring no longer voltage drifts, so we are analyzing the effects of the voltage drifts. This is going on in real time, so that means that it's possible to set immediate counteractions that the stack will not be damaged. And this is possible only by cabling of by one wire, so to take the entire stack sum signal. So the approach is only superimpose a current into the stack and measuring the answer of the signal. Under normal operation conditions, the signal which is superimposed is the same on the outlet, but if there is a critical condition, the superimposed signal will be somehow distorted, and we can measure also spectral components. And in particular, on critical operation conditions, harmonics are formed. The approach is simple, analysis on stack level, and with this approach we can determine 3 different failure modes. This means one is membrane dryout, low media, and liquid water. This is the basic principle. So this is a basic characteristic of a fuel cell. So we have here, when everything is going fine, then the stack is operating here on the linear part, and then the input signal is not distorted. But if the stack is somehow, or a stack is somehow in a critical condition, then the characteristic is moved out from the linear part, and it's going there in this direction, and then harmonic distortions are formed of the superimposed signal, and this will distort, and our device can distinguish between the failure modes before I have explained. So very simple approach, just have to measure the stack current and one additional wire for superimpose the current into the stack. Also, it's possible a very fast THDA measurement and impedance spectroscopy, and also the results can be connected by CAN or serial interface to the fuel cell controller or to the graphical user interface. This is basically the hardware device for laboratory purposes. And this is the graphical user interface. So it's already available as a serious device for lab purposes. Also possible is that this methodology can also be integrated into a fuel cell vehicle controller, and no additional hardware is required for that purpose. One option of this device is also a fast online impedance spectroscopy. So 4 frequencies can be chosen in the range of 1 to 10 kilohertz, and every 5 seconds you will get a new value. This is possible up to 500 volt stack voltage, and maximum of 2 amp current imposition, superimposition is possible. Just one measuring example. So on the right-hand side, so everything is on safe conditions. So there is the stack is operating at 450 amps, baseline with an 80% relative humidity. Here on this, so the gray line is a low media signal, the blue line is liquid water, and the orange line is dry out. These are these 3 failure modes which our device provides online. So for one example for low media and dry out is a decrease of the relative humidity. This means for the, of course, low dry out of the stack. So when the relative humidity is decreased, and also this dry out leads to a lower conductivity of the membrane, and this is why also the low media signal is also indicating this effect. Here on the left-hand side, there is one example for the rapid cool down. Here the stack temperature is going down from about 70 to 50, and this causes, of course, liquid water, and this liquid water are blocking the channels, and this is why also this low media signal is showing a big effect here. So now I'm going to show you one example of our last research projects. This is a possibility to get a multi-dimensional THDA approach. So there is to integrate 2 sensor blades into the stack. Then there is these 2 blades have 100, for example, 100 segments. And then you get information about these 100 segments. You can see every segment of this cell. You can see if there is an issue with membrane dry out, low media, or liquid water. This was a research project, and the sensor blades are provided from our partner S++, with which they have also a booth opposite of AVL here at the fair. So the next one, I hope it will work. This should be a movie. Maybe you can start it. Is it possible? Thank you very much. Just a measurement example. So there's the air lambda is reduced stepwise from 2.0 up to 1.49. And here you see the reactions of the different segments of the cell regarding the reducement of the lambda. So the flow is from this direction to here. So you see a lot of effects on the end of the cell. Okay. So now I'm going to summarize. So the THDA is intended to monitor different fuel cell stacks and also real product applications. That's like fuel cell vehicles. So as I told before, this methodology can also be integrated into fuel cell controllers in a car. It's possible to monitor range extenders, CHP, also micro CHPs, and for example, auxiliary power units. Currently, this device can detect 3 different failure modes. That's tryout, membrane tryout, low, media, and liquid water. And it's also possible to perform fast impedance spectroscopy. For example, every half a second, 4 frequencies can be chosen from 1 up to 10 kilohertz. The laboratory device is commercially available and can be seen at our booth. Currently, this approach is under validation of 7 different car OEMs so far, and currently, as an outlook, it's also possible to have a license agreement with AVL, so this methodology can be integrated in a fuel cell vehicle. Now, ongoing developments are going in this direction to separate these effects from anode to cathode, and also the application will be extended for SOFC and SOHC and also PEM electrolyzers in current research projects. So thank you for your attention. So please visit us at our booth E55. I'm looking forward to your questions. Thank you very much.
Thank you very much also from my side. You may ask your question at this time. You can raise your hands and I can take your questions. If you want, you can also take your question to the booth, and I really like this map, so it's E55. If you just walk straight and then take a right, you can ask all your question, and then Mr. Richard Schauperl will be welcoming you there. Once again, big hands, please. Thank you.
Thank you very much.
Please stay seated for our next presentation. We'll hear representative, the deputy chairman of the German Wasserstoff-Brennstoffzelle-Verband, and that will start in a few minutes' time. So please come and have a seat here in our technical forum. We'll have coffee and tea. It's all in the house, and there's a lovely lady walking around serving you these drinks.